All right, so I want to welcome everybody to our 32nd SLiTHER webinar. And today we have a special guest. We have Justin Pratt, who is going to take us through some chemistry education research. And I know that, like many of you, you probably aren't all that familiar with this side of chemistry. So I'm really excited to hear what you have to say. And with that, we will let our speaker. Can you share your screen?
Yeah.
Okay.
All right. So as the title says, I'm going to try to walk us through these kind of three different disciplines that focus on some sort of education research in some format. But before we do that, of course, I'm going to have some sort of audience participation. So, there we go. So I have this poll everywhere poll. So there's a link at the top of this. That's pollev.com/JustinPratt452. And if you go there, it should let you answer this. And it's just, I want to know, what does everyone that came to this webinar want to learn from this discussion? Okay, here's one focused on methods. I will definitely talk about some different methods. Ooh, the unexpected hurdles. That's a good one. I don't have it in my presentation, but we should definitely talk about it in our discussion. How to begin the process of evaluating learning. We'll touch on that with our methods, so we'll get there. Navigating IRB, that relates to the unexpected hurdles, so we should definitely talk about IRB later. Ways to help myself and others with the various frameworks and how that influence research design. Yeah, so frameworks are really important in this type of work. And so when we get to our discussion, I'll make sure to touch on frameworks. So these are really good for me to know. It looks like at least half of these I'll have already built into the presentation, so that's good. A better way to explain CER and SOTL. Yeah, so I'll cover that. So these are great, and it looks like at least what I envisioned for the presentation and discussion matches for the most part what everyone wants. So that's great. I do want to put in a word of caution before I talk about anything. We're going to be talking about three different disciplines that typically function separately. So that means there's no agreed upon descriptions, definitions. Each field kind of works on their own. And so I will talk through some general trends and observations from my background and help try to parse these out. But I will say that this is just me, one chemistry education researcher. So don't take everything I say as 100% of facts. There's definitely some nuances here. But with that, let's start talking about these different disciplines. And so the first discipline I want to touch on is just the science education general discipline. And so this discipline, researchers focus at both types of education levels, so K-12, so pre-college students, as well as anything that's in higher education. And it's focused on this idea of generalizable knowledge. And that really just means knowledge that other people can use in the future. So it's much like our traditional chemistry results that we try to find, here's a new molecule, here's the data that shows that what it looks like and why I know it's that way. Now go use this in some other research capacity. That's what science education is doing. It's focused on creating some sort of knowledge for others to use. But this diagram I have really helps kind of show the perspective of science educators. They come from an education first perspective. Science education is housed typically in an education department at an institution. And so they come from, I'm an educator, I understand teaching and learning, and now I want to focus on different science contexts. And so keeping that differentiation of education first, when you look at, say, the backgrounds of people in this field, they don't necessarily have advanced degrees in a science discipline. They may have just a bachelor's in, say, chemistry, if that was their interest, and then they got a master's or a PhD in education. And so they don't typically have advanced coursework beyond the undergraduate. Now, that does vary on places, on different school requirements. But that's what's different from what I am, which is a discipline-based education researcher. And so that's the general term, it's called DBER. And really it's at individual disciplines focused on education. And so you can see it still has the same initial foci. We're focused on this, we can focus on the same population, so pre-college and post-college. We focus on trying to create knowledge that other people can use to advance our field. But DBER folks come from a discipline background. They come from the science. And so, for example, I have a bachelor's in chemistry and my PhD is from a chemistry department. So I have advanced coursework in chemistry, but my research area focuses on how we teach and learn within chemistry. And so we have biology, physics, earth science, geology, all of these are different disciplines that have education researchers. So when you hear the term CER, that just means chemistry education research. And so that's kind of where I'm at. But now that we look at these two disciplines, they have similar outcomes. They want to have generalizable knowledge. They want to understand teaching and learning. But given the perspective, either from an education standpoint or a disciplinary standpoint, the types of questions that they try to answer really do vary. And so I'm going to give you some example research questions for the two different disciplines. And so if we look at science education, the two examples here are focused on this idea kind of affective learning, which is the kind of emotional thoughts and feelings behind learning. And so this first one is focused on STEM identity of girls in an all African-American school and how they develop their identity as either a scientist or something like that. And then the second research question is all about spatial thinking and spatial awareness. So that's a skill that people have. And whether or not in this study are there differences between gender groups. And so you can see from these questions that they're coming from like a holistic standpoint. Their questions aren't tied to a chemistry class, a physics class, a biology class. This idea of identity or spatial thinking span a lot of science disciplines. And that's really where science education typically focuses. They look at questions that are across multiple areas. As opposed to DBER folks, like I have here on the right side, our questions are much more focused on specifics in the discipline. So I gave two examples for chemistry, but you can imagine biology or physics ones. So the first one's a content knowledge type of question. So what misconceptions do students have about acids and bases before and after instruction? So you can see that's kind of like a pre-post design, but it's focused on content that's specific to chemistry. The second question is back to that affective idea, these thoughts, these feelings behind learning, but it's still tied specifically to chemistry. This idea of chemistry self-concept and chemistry self-efficacy are chemistry first ideas And so that's the type of perspective that DBER people bring, is their questions are inherent to the discipline. But what I haven't talked about then is this SOTL idea, this third discipline. And so SOTL is the Scholarship of Teaching and Learning. That's the formal title of it. And there's this really great quote from Lee Shulman that helps kind of summarize this idea of, as a teacher, you should be having scholarly teaching approaches, which leads to you conducting SOTL. And so scholarly teaching, according to Shulman, is what we all should be doing. In all of our teaching practices, we should be working to meet, high standards, groundedness. So perhaps it's grounded in novel research or new theories that we have. It's open and you focus on clarity, but you keep complexity. So we are teachers. We try to challenge our students productively to help them learn. That's what a scholarly teacher does, and they reflect on that. Did it work? Did it not work? Was that question too hard? Was my exam too long and that's why everyone failed? Those types of reflective questions, that's what a scholarly teacher does. When it moves into the realm of SOTL is this last bolded part where you start sharing it publicly. So you want to be publicly reviewed in some sort of fashion so your peers can build on it. That's really where SOTL comes to play, is when you start thinking, hey, I did this in my classroom, I reflected on it, let's get some outside perspective. Let's hear what other people might think. That's where SOTL comes in. And so a lot of us are probably doing scholarly teaching. We look at our results, we wonder why that exam didn't go well, or that question you asked in class, you thought everyone would get it and they didn't. We're already reflecting. And so moving to SOTL isn't a big leap for most people. It's now putting that public part in there, sharing it out. But let's compare the three disciplines. And so I've got up right now just the science education and DBER, and how they share the focus of K-12 and higher education, as well as this generalizable knowledge idea. SOTL is very different from those. SOTL only applies to higher education, so it does not apply to anything below college. They have a different type of research that applies to, like say, high school that relates to SOTL, but SOTL itself is only for higher education, so looking at college professors and college teaching. The focus here is on advancing teaching and learning through study and reflection. So it's not preparing generalizable knowledge that, this is the only way to teach it because the data says it's the best. That's not what SOTL is. It's about trying to improve yourself, improving your colleagues, and kind of your sphere of influence by studying yourself, studying your students, and reflecting on it. And so it's really this idea of a reflective practitioner. That may be a term you've heard before about being a professor, where you focus and reflect yourself is a very important tool and skill set. And then lastly, what makes SOTL very unique is the focus on context. When you're conducting SOTL, you might not collect what I would call traditional education data. You might not, ask a research question where you give a survey or give a test. Your data could be your reflection. I gave this activity, the students complained. So obviously it was not a great activity. The next time I did it, I changed it and the students complained less. So somehow it's better. That might be the type of data you bring in a SOTL type of report. And you might be analyzing your own reflections. Maybe it's over a couple years and you're seeing how your reflections change. So the context of what is your classroom, who are you as an instructor, what's your philosophy of teaching, all of that becomes really important in SOTL because you're typically studying your classroom, your students. And so understanding the context you're in is important for other people. And so this whole SOTL idea and relating to a reflective practitioner, that's what this picture or diagram on the right here is, this idea of trying to be a reflective practitioner. This is what me as an educator hope most faculty are doing, even if you're not doing it purposefully, you might be doing it unintentionally, where you teach your course and you collect some data. You look at the distribution of the final grades, you look at maybe specific exams, maybe you look at specific topics like I studied inorganic chemistry, so I really care about the section where we teach MO. So maybe that's the area that I want to reflect on from my background. And then you make some sort of changes. Change your PowerPoint, change your exam, change the way you instruct it, give an activity, some sort of change based on your results. And then you just keep doing that process. And it becomes this cyclic cycle of reflecting, teaching, and reflecting again. That's what SOTL is really about. And so this quote here from Finlay about learning through and from experience and new insights of yourself and your practice. So it's all about the experience of the professor, of the teacher. But SOTL is conducted by disciplinary specialists. So a chemist would be conducting SOTL on their classroom. A physicist would be conducting SOTL on their classroom. So we're not talking about people that identify as from the education perspective. We're talking about disciplinary specialists, scientists, chemists, who are taking a structured SOTL approach to their teaching. And then again, that sharing out. That's really the kicker for SOTL. If you're not sharing out your work in some way, either with your department, your colleagues, or in a broader scale, like at a conference, then it's not SOTL. It's just scholarly teaching. And that one step further is all you need to do to turn it into SOTL. Now, if you're like me, you are a little confused then about all of these three different disciplines. Science education definitely sounds different. There are these educators that don't necessarily have a content background, and they focus on these big cross-disciplinary ideas. But when you talk about SOTL and DBER, we still have disciplinary specialists studying something in their teaching, sharing it out in some way. So really, what's the big difference then between SOTL and DBER? And shockingly, it's not a big difference. It's kind of considered a continuum in the research world, where SOTL's kind of on one end of the spectrum and full-on DBER is the other side. And studies fall anywhere on this continuum. So for example, one of my dissertation studies focused on one classroom, a small set of students, but we shared out the work a little more broadly. And we tried to interpret it in terms of ideas that more people could understand besides my context. So in terms of this continuum, I'm definitely not all the way in DBER because it's not generalizable. It's studied maybe 10 students, it's a small amount, but it's not SOTL because of the research questions I asked and how broadly it was shared out. So it's somewhere in the middle. So even me as a person that identifies as a chemistry education researcher, my work still falls somewhere on this continuum, either fully DBER or somewhere that's straddling the line with SOTL. Okay, now looking at all those questions that everyone wanted to learn from this talk, I'm actually going to give us a pause before we move into thinking about specific methods and how to do these studies. So I want to pause and open it up for questions and discussion related to just what are the disciplines, what are the differences. That way we're ready to move on to how to do these in a little bit. So feel free to unmute, talk, you can put stuff in the chat, anything that we want to kind of either have a question or a discussion about.
If you have a question, just go ahead and unmute yourself and well, ask your question.
And maybe you don't have questions yet. Maybe it's just I fire hosed information at you and you're still processing it. That's totally okay. I just want to make sure we're kind of all in the same place before we move on. So here's a question in the chat. One of the things I've noticed is that journals that publish SOTL are interested in work that is more generally applicable to other disciplines. Is there any outlet for chemistry specific work that is not CER? That is a great question. And so for those of you that haven't perused, say, SOTL specific journals, they do have a desire that whatever you're sharing can be read more beyond just either a chemistry person or even like a physical science person, something that more types of people can learn from. And that's that whole sharing out your work. People want to learn how can I take your method and apply it to my context, even if it's a different discipline, not chemistry. And so if you're wanting to share chemistry specific, there are outlets, and I have a list of them at the end of this presentation. But the Journal of Chemical Education is actually a really good place for SOTL work. And I'll give some examples that show kind of the difference between a CER publication in the journal or a SOTL publication in the journal. So hold on to that for a little bit. Yeah, SOTL work on labs is not applicable outside of STEM. Yeah, that's an important thing. If you look at the Journal of Chemical Education or stuff that's coming out that's chemistry specific, it is a lot of people studying the lab. That's where we're trying to make things better, more hands-on for students. And that is not as applicable to, say, other disciplines, say biology, for example. They have a different structure to labs than we do. And so it is a tough niche to be in, depending on your focus. Are there any other questions or concerns before we start moving on? Okay, well, I'll go ahead and move on, but feel free to put other questions in the chat as they come up. And then we will have a larger discussion at the end of the presentation where we can all just kind of reflect on all of these ideas. Okay, so we've talked about just what are the disciplines, what are the differences, but we haven't talked about how to do them. And so that's what I want to move into. But what I want to start with is ways that you might already be conducting SOTL. I can get, there we go. Most of us, if you're here at this presentation, you're involved with Ionic and Viper in some format for the most part. And that is a place where people share their work. And so there's teaching resources, they're called learning objects on the Viper website. People share lessons, labs, syllabi, resources. But one of the requirements is there has to be some sort of data. Now, when I say data, a lot of people are like, oh God, education data. These don't have to be some in-depth analysis of data. It could be your reflections. I gave it, the students didn't complain, so that's a pretty good outcome. That might be some of your data, or at the end, the students, like over half the class was able to answer this question correctly. That would be a type of data you could share with a learning object on the Viper website. And so I've just given 2 examples of the content areas that have different learning objects on the website, but there are tons of them out there, different disciplines or different contexts and content related to general chemistry and inorganic and physical chemistry. And so sharing your work on that website is one way to practice SOTL, sharing your work, getting it out there to other people. Attending and giving SLiTHERs is another SOTL idea. Now, what I'm sharing today might not really be SOTL because it's not really my research or my outcomes of my teaching. But the previous SLiTHERs that have focused on specific tools or specific ways of instruction, those are perfect example of SOTL. It's not a written publication, it's basically a presentation version that it's now housed on YouTube, and you could link it on a CV in a report. But giving a SLiTHER or attending a SLiTHER is one way to be involved in the practice of SOTL. And similarly, at least with Ionic, we have another type of video series called Nano Chats. It's a much smaller, shorter version of a SLiTHER, but it's much more focused on teaching specific advice. And so what's going on currently, say this semester, is a series called The Newbies. So it's the bottom right corner here. And that's 2 professors at the Naval Academy who are teaching inorganic chemistry either for the first time or the first time in a long time. And so they're reflecting on how did it go? Do people have advice? I gave this lecture and oh my God, it went terribly. Did anyone else have that experience? What do I do? So that is a perfect example of SOTL, sharing what you're doing, trying to get advice, and trying to learn from your community. Now, all 3 of these are specific to Ionic and Viper because I'm involved with those groups, and that's what this SLiTHER is for. But there are other ways you can be involved in sharing out your work, like going to conferences. The biennial conference on chemical education, for example, that's every other summer, is a very big kind of SOTL conference. It's all about bringing together instructors that teach chemistry at all levels. Some people share CER work, some people share SOTL work, some people do workshops to teach skills. And so that's a perfect other example of ways you can get involved and share your work out. But in terms of learning specific methods, I have some resources and some general advice to start with. And so I'm kind of lumping DBER and SOTL together since they have a big blurred line between them. But really, when you want to conduct this work, your starting point is much the same as traditional bench chemistry work. You've got to have some sort of curiosity, some idea you want to look at. Maybe it's a hypothesis, maybe it's a research question, but you have to have something you're curious about. But now we're talking about ways we're either teaching a subject or the way my students are learning the subject. That's the difference, is your context now is about your students or yourself, for example. You're still going to conduct it very deliberately. You're going to design your experiment. You might have controls, just like you would have in a bench project, things you don't want to factor into your analysis. It's typically grounded in evidence, so you have to show proof. Proof is a bad word in science, but you have to show evidence to support your ideas. So you have to give an NMR to prove or support that that's the molecule you made. We have to do the same in education research. We have to give evidence and data. It just might not be the data you've looked at before. It might be quotes. It might be a summary as opposed to numbers or a figure. And then the results get shared out in some way, either formally with peer review or informally. Say the Ionic website has its own review process. It's not really the in-depth peer review that a journal would have, but there is a review process there with learning objects with Ionic. But then on the screen here are 4 different books, and I've included the references at the bottom of the page of great places to get some resources. The first one is less about how to do DBER or discipline-based education research. It's more of a review and a history. How did the field come about? Which, fun fact, physics were the first people to really start DBER as a field, and then chemistry came second, biology came third, and then geology came last, for example. It gives you a nice history and context, and it ends with future directions. Where are areas that more research needs to happen? Now that was in 2012, so those future directions might not be the most, timely now, but those are places you could look to get inspired on things you might want to look at in your teaching. The middle 2 books are specifically made for chemistry education researchers. I will say they're not technical, so anyone can read these, but they are tips and tricks on how to do different types of this research, either different ways to analyze your data, different ways to collect your data, because when we're talking about education, your data can span being a video, it could be a recording of someone doing something, it could be written work, it could be a syllabus. So our data varies, and then the way you analyze that varies. And then so the nuts and bolts of chemistry education research, as well as the tools of chemistry education research, are really great resources. And they're from an ACS symposium series. So they are peer reviewed. And then the last resource is specifically from a SOTL environment. It's tips and tricks about doing SOTL. And so I just want to provide these as resources for future reading. But let's dive in and look at different types of data that you can get. Now, for some of you, this is going to be obvious and a review. Some of you, it's going to be, oh, that's weird, but that's okay. Stay with me. There are 2 main types of methods and data that are common in DBER and SOTL work. There's quantitative and qualitative. Quantitative is what most of you are probably comfortable with and most experienced with. The focus is on discovering some facts or phenomenon. And I want to zoom in on this idea, assumes a fixed and measurable reality. This is a really important point for quantitative work. You're assuming that when you take a measurement, Nothing is going to change if you talk to your lab partner, talk to a colleague, walk away and come back. Those molecules should behave the same. We assume that they will behave in a fixed way. And so that's really important for quantitative work, is to know that perspective. And I will say it's very different in qualitative work. And so I'll share that in a second. But in terms of your methods, you collect data by measuring something. That's what quantitative methods do. You could be measuring with a survey, it could be a test, it could be an NMR. You measure something, and then you analyze it typically with statistics, and you typically report it in some way with statistics. So for example, peak heights and integrating your peaks in an NMR, that's your statistics that you're using to interpret it and then share your findings. Now, qualitative methods are very different. We're talking about words now. We're not going to be talking about numbers. And so the conceptual ideas here is we're trying to understand the why of ideas. So understanding behavior and perspectives that let us know why something happens or why someone behaves the way they do. And this assumption of a dynamic and negotiated reality. So that's some really weird sounding words. But the idea is just by talking to someone, you might change what they think. So by me giving this presentation to you, your ideas and thoughts behind what DBER is, what SOTL is, should change after the end of this presentation. If I interviewed you before it versus after it, I'd get different findings because your experience changed you, and therefore your thoughts have changed. That's that dynamic and negotiated reality, where we're looking at a single instance where we know that in a minute, if they got sick or someone walked in and opened a window, they might feel differently and their response might change. And so that's a different perspective and approach in qualitative work that most people are a little uncomfortable with. When you come from a traditional bench chemistry background, this idea that there might be more than one correct answer when you analyze the same data, that's really a common idea that a lot of people struggle with when they first get into this world. But if we look at the types of data here, we're collecting information about people is typically what we're doing in qualitative work. So it might be an observation, you might interview them, you might collect documents from them. And then the way it's analyzed isn't with statistics. You analyze it by trying to group ideas together. So are there categories or themes of different ideas that I saw in my interview? Did half of my group talk about the same idea? That's something that's standing out. That's important because over half of them talked about it. And then when you report it, you report first in the language of your participants. So some people say if they speak multiple languages, sometimes they conduct interviews in a different language than they publish in. Say Spanish, they conduct the interview in, but they're going to publish in English. So depending on the context, you want to present as much of the original words of your participant as possible. So you might give the Spanish quotation and then a translated version, because in translation, things do change a little bit. And so qualitative methods are really more about the why and the how, and quantitative methods really are about the what. And so if we look at the specific tools you might use, there is overlap between quantitative and qualitative methods. So you'll see that surveys and observations are listed in both sides of the table. You can have a quantitative survey where, say you've probably taken one. On a scale of 1 to 10, how confident are you? Do you strongly agree or strongly disagree with this statement? Those would give you quantitative data that you could analyze. Or observations, someone watches you teach. Maybe they have a rubric that they're filling out by seeing you do different things in your classroom. That would be observations that give you quantitative data, so numbers. But surveys and observations can also be qualitative. Maybe you ask open-ended questions in a survey. Explain to me something. Why do you feel that way? That's going to give you words and description that's qualitative. Similarly with observations, I don't know about you, but most of my teaching observations as a professor have been very qualitative. It's my chair or a colleague in the department kind of just reflecting on what they saw me do and giving advice and feedback. That's a qualitative observation. They weren't filling out a form with numbers on it. It's more of a judgment call. And so underneath the table, it's kind of a general perspective. Once again, I'm going to point to this lovely caution sign in the corner that this is just one way of thinking about quantitative and qualitative data. But quantitative, you're trying to confirm or test something. So that's typically you have a theory or a hypothesis that you're trying to test based on your data. And then qualitative methods is more about understanding something, the thoughts, the experiences. So for shorthand, we typically say, what's the what in quantitative methods? And then the why and the how comes in with qualitative methods. Now, there is a third type of study that uses mixed methods. And it's really just some combination of quantitative and qualitative methods. Sometimes you might give a survey that gives you numeric responses. And from that survey results, you pick people to interview. So then you interview them. So that's a mixed method study where you first do a survey, and then from those results, you then pick people to do an interview. Another example is maybe you want to learn how do students think about, we'll return to my example of acids and bases. Maybe you give them a test on acids and bases, and that gives you some numeric score. But then you sit down and interview them and ask them to talk through a problem. Now you have two sets of data about the same idea. That's another way of doing mixed methods where two sets of data can be combined together to get bigger meaning than them by themselves. And so those are just different approaches to doing this type of work. But what I think is more useful for us as a group now is to think through some examples to really get a sense of what type of data were used, why is it that way? And I think that'll help us kind of process this as a group. And so my first example I want to talk through is a DBER example that used quantitative methods. And it's actually a project with Ionic and Viper called the Viper Fellows Project. And so if you aren't aware of what this is, we have a 5-year NSF grant focused on helping inorganic faculty members improve their teaching. And our big research question here is, how does faculty change impact student learning and experiences? And so this reflective practitioner model that I showed earlier is really the basis of our project. We're trying to use professional development workshops to help faculty members change and using data on their students to inform those decisions. And so as part of this, we did collect quantitative data. So we collected some cognitive, so that's like content knowledge data. So we used an ACS exam, so the Foundations of Inorganic Chemistry exam. We also wanted to collect some of that affective data, so the thoughts and the feelings behind the learning. With that one, we used a published survey called the Academic Motivation Scale for Chemistry. And I've just given you the prompt and the options down at the bottom. So this is something that you've probably experienced in a survey you've taken before. It's like a Likert scale, strongly agree to strongly disagree. That's the type of data we got from that. So both of these gave us numeric results that we could analyze to try to hone in on if the faculty member changed, how did that impact the students? And so these are measures of the students' experiences that we can then use to interpret things. But this project was focused on faculty. So in addition to quantitative methods, we also collect qualitative methods about the faculty member. We wanted to know how they changed, what process and perspectives do they take in their changing of themselves to then change their course. And so we're doing interviews with the faculty member here. So that's qualitative. And we did it before the project, so before they ever attended a workshop or made any changes to their teaching. And then at the very end of the program, so after their full 2-year experience, we interviewed them again. And so that is helping us understand how they changed from the beginning to the end of the project, and then relate that then to the student data that we got. So technically, this is a mixed method study because we're collecting quantitative and qualitative and using it together. But our focus was on, if the faculty member changes, how does that impact student learning? And so that's a very common question you'll see in a lot of DBER or SOTL type work. If I make this specific change, how does it impact my students? For some other examples though, I want to move away from just thinking about how does teaching impact students, because there's more to CER and SOTL work than just how did my teaching change or how did my students change. And so this example is a really recent article, so published this year, from CERP, so that's Chemistry Education Research and Practice. And if you look at the title of the article, it's the development of the assessment of student knowledge of green chemistry principles. So the researchers developed a new survey. We call it an instrument in our world, so don't confuse that with like a UV Viz or an NMR, but it's an instrument, it's a data collection tool, but this type of work is developing the tool. And so it's very quantitative. You can see a nice little figure here on the right where they have to focus on these ideas of validity and reliability. So those are common ideas. They're related to precision and accuracy in bench chemistry work. So reliability is more about precision and validity is more about accuracy. But they have to look at the data and understand how well did my new survey, my tool work. So this is kind of like the analytical chemist of CER, people that develop new tools for other people to use. That is one kind of frame and lens that people approach their CER research with. Another lens, instead of focusing on developing instruments, we focus on developing teaching tools. So this is where people, publish labs in the Journal of Chemical Education. But this example isn't a lab, it's a new app that people developed. And what I want to point to is it's a technology report. So this wasn't submitted to the journal as a chemistry education research article. So the Journal of Chemical Education accepts more than just those traditional research papers. This one is about developing a new tool to help students think about stress and strain of materials. And so you can see that they gave a nice figure to show us what their app looked like. But in order for it to be published, like SOTL work, you need some sort of data. So they gave us a little bit of data. The paper is very much about the tool and what it looks like, how it was developed, and just a little bit of data to show us, did it work? Was it a useful tool? And so you can see they did an entry test and a final test. And so they're looking at how the histogram shifts, hopefully for the better, after they experience this new app. And so this is really kind of a SOTL project, developing a new tool, seeing if it worked, and sharing it with other people. And it's in the Journal of Chemical Education, just like regular traditional CER articles are. And speaking of traditional CER articles, here's one that's near and dear to hopefully all of us. This big work that focused on trying to understand what do we all teach in our inorganic courses. And so this was considered a chemistry education research article. It was submitted under that line when it was submitted to the journal. And the focus was using a survey. So this was a mixture of qualitative and quantitative questions on this survey. Some were multiple choice and some were short answer. And then in the end, the researchers then analyzed it with some fairly advanced statistics. I'm not going to go through those because it's a little overwhelming for some people. But they analyzed the data and came to some conclusions about different types of courses across the country. And so you can see this idea of generalizable idea that was kind of what the focus of DBER is. I will say generalizable means applicable to a lot of people. There's a formal definition in the research world for us that doesn't apply here. So I just want to put that out there. But the goal here was trying to understand a large context, so not a single classroom, a lot of classrooms across the country. And that's sometimes where the SOTL DBER line is. It's your scope. It's one tiny classroom, just yours. It might be a SOTL project. If it's a lot of different classrooms or a lot of different schools, it might be a DBER project. It kind of depends on your focus. And so this example is a chemistry education research article that was quantitative. I do want to give you an example of a qualitative one, which if you haven't looked at this and you are a graduate advisor, I would heavily encourage you to look up this very recent article in the Journal of Chemical Education. But what these researchers are looking at is they wanted to understand how graduate students interact with their advisors and how they communicate when things don't go the way you want, when there's conflict. and they use 100% qualitative methods. So they use interviews. I've given some examples from their paper. There's different types of questions. So you can see one says structured, there's unstructured. Structured just is something that you have kind of from the beginning. And then unstructured are ones that come up as you're talking to your participant. But see how all of these are just open-ended questions. You're trying to get the person to talk and share their ideas. And then these follow-ups, these unstructured ones, are a lot of, can you expand on that? Why did you think that? Just trying to get more detail, because qualitative work, once again, is about the why and the how. In order to answer that, you need, we call it thick description. You need a lot of info from your participants. And so those are some examples of studies and the different kind of approaches they used. I will say that I only showed articles from 2 journals, the Journal of Chemical Education and Chemistry Education Research and Practice. These are 2, I would say, DBER specific journals for chemistry, but the Journal of Chemical Education also publishes SOTL type projects. I would say CERP does not. It's a pretty traditional journal that's looking for DBER type work, but those are 2 specific to chemistry. The next 2 are just science in general. So a lot of science education work gets published in these 2. So it's the International Journal of Science Education, as well as the Journal of Research and Science Teaching. But you'll find CER, chemistry-specific work in those journals. But you're going to find other disciplines too, biology, physics, chemistry, general science, as well as like K through 12 work and higher ed work. So these journals are a lot more broad of a focus, so you have a lot more different types of articles there. And then I wanted to point to the last one here. It's the Teaching and Learning Inquiry Journal, and it's from the International Society for the Scholarship of Teaching and Learning. It is a whole group dedicated to SOTL, and this is a journal for SOTL. And so I've reviewed for them before. They have a very supportive process because most people that are doing this work have never written education type articles. And so that journal specifically is more about developmental and helping you improve your work and making sure it's readable by more than just your discipline. And so if you want to get started in this area, I encourage you to just browse these journals. Get inspired by things. So that's something I do. If I'm stuck and I want a new research project, I go and look what's recently been published. What's interesting, what excites me, and how can I incorporate that into a new thing? And so just perusing these is a great idea. And then seeing what methods did they use. I will say that you're going to get frustrated with the amount of jargon in these articles, okay? But chemists do it too. You go read, the Journal of Organic Chemistry, and as an inorganic person, they use stuff that I am so lost on, and that's okay. It's not my area. I'm an inorganic chemist and an education researcher. So I just want to give you that little confidence boost that there's going to be words that you don't know, and that's because it's a new discipline. So it's like trying to change from a 5-year PhD in chemistry to a 5-year PhD in education. There is a lot of learning and a big learning curve, but the only really way to do it is to kind of immerse yourself in it, read articles, talk with people, and that's really the best way to get started. And so with that, that is the end of my formal presentation. I would open it up for some discussion. I know people wanted to talk about this idea of IRB and frameworks, and so I'm happy to chat about those if people want. But I'm going to go ahead and stop sharing and let us turn to a big group discussion.
All right, well, thank you so much, Justin. I guess, what are our pressing questions that we want to ask?
I could start by answering a little bit about the IRB framework questions, if that would help people kind of process their ideas. When we're talking about education research, you're studying people. So that's different than, going into the lab and studying molecules. People have thoughts, they have feelings. And so we have to make sure that we treat people ethically in research. And so that's this idea of IRB. It stands for Institution Review Board. So every institution should have one of these. It's more common at bigger schools, particularly with large psychology departments. But it's basically a panel that reviews your plan of study, whatever you want to do, and make sure that it's going to be in line with both the law on how we have to treat people in research, as well as the ethics on how we treat people in research. And so it is kind of a big learning curve. There's a lot of history you kind of have to know and some training you have to go through to submit an IRB application, but it's more about you learning what the rules are for doing research with humans. So for example, none of the studies that you can read tell you who the people are. You never know a name of the people that were interviewed. You typically don't even know the specific school. If you ever read it, it's like a school in the Midwest of the country, a large school in the South. So they don't tell you specifically, they hint at it, but those are some of the ways we have to go about maintaining the confidentiality and anonymity of the participants. And so that's what IRB is. And so any study has to be approved before you do it. SOTL is a little bit different because you're conducting it in your own classroom. But depending on the journal, they may require IRB approval to publish it, but there are ways to get post IRB approval. So you've already done your little study, your SOTL project in your classroom. You can request for approval to publish that work, even though it's already been conducted. So that's another route for you folks that might be in the SOTL world. Are there questions about IRB? Okay. And the other question that was at the beginning was about frameworks. So this is something I didn't really touch on at all in my presentation. It's this idea of frameworks. And so when you think about your traditional bench chemistry work, you always go and look what's been done before. How do I make that functional group so I can add it to this molecule? You look up what's done before. We do that in education research. We try to see what's been done before. But we also use a lot of frameworks that help guide us. And so typically what's common is frameworks related to how the brain works. So if you're studying student learning, how cognitive scientists say your brain processes information to learn something guides how you might ask questions, what types of questions you ask, or how you format whatever you're doing. So we use frameworks to design studies. So maybe one framework, for example, is self-determination theory. Most of you have no idea what that means, but it has components. So maybe I design a study where I ask questions related to every component. So the framework informed how I developed my study. You also use frameworks to analyze your data. So if I think about a framework on learning, so meaningful learning theory is an example of a framework about learning. And it talks about, do you memorize content or do you learn it in a meaningful way? Maybe I look at results from my test of students and I find that certain topics they get, but the topics that expand or apply those, they have no idea what they're doing. And so I'm seeing that they might have memorized the facts, but they can't apply it and use it later. So that would be a way I could use a framework to interpret my results in a way that makes sense in terms of either brain science or other ways of analyzing data. And so I will say, if you ever take a graduate course on frameworks, it is like years, okay? Because there's so many different frameworks, some for methods, some for analysis, some for design, and it all depends on what you need. And so for me, I learn new frameworks when I need a new framework. I hit a wall, I have a new topic that frameworks I know don't help, so I need a new framework. And so I will say there is another book about some frameworks by George Bodner. I can find that really quickly on the internet. He made it was available as a publication, but then Pearson upped the price. So then they made it available for free online. Let's see, is this the one? I'll just tell you what the title is. It's the Theoretical Frameworks for Research and Science and Chemistry and Science Education. And you can find it with the University of Ottawa, I think, are the ones that have hosted it. So you can get a free copy of it, but it talks through different frameworks for designing a study. So for example, there's frameworks about race and ethnicity, like critical race theory is discussed in there. There's frameworks about learning, like constructivism is in there. And so it describes them and then gives you some examples of how you might use it. And so that's another useful tool. So I'll repeat it. It's the Theoretical Frameworks for Research in Chemistry and Science Education by George Bodner and Mary Kate Orgill. And I would be happy to give a link to that, like in a follow-up email to everyone. I think I've addressed the unanswered things that people wanted from the beginning of the presentation. So now let's turn it to you. What other things do you want to talk about?
So I had a quick question that I think actually kind of dovetails from what you were just talking about. So as a chemist, right, I look up synthetic procedures or studies that have been done in the lab. And if it doesn't work for me the way that it works when it's published, that's probably not great science, right? And I think you talked about this a little bit of like the difference between experimental science and educational or psychology studies. So let's say I'm reading papers about applying, chemical education research into my classroom. What are some things I should look out for, or how might I better apply that in my kind of day-to-day life, knowing that people are different and I can't just, apply a synthetic procedure to a classroom like I could in the lab?
Yeah, that's a very important thing. You read an article that says, if you teach this way, it's better. But how do you know it works for your students, your context? And so it is an important thing to think about. With education studies, you're typically required to provide some sort of good description of your context. So maybe the class size, the course, the semester, depending on the study, maybe the background of the professor, how many years of experience do they have? And so that context helps put the findings into context. It helps you interpret it and, okay, I'm at a small school. So will my close-knit group of 8 students act the same way as a 150-person classroom? Likely not. So there might be changes to that method that you have to apply to make it work for you. And so that's that whole shared reality. Your students just might be different. But what you would do is you would try it and see. You don't know if they're different, so try it. You think of your classroom can be an experiment. Try a new activity, try a new approach. If it bombs, that's okay. I've done it. The next class period, you just do something different and fix it. And so be a little experimental in your approaches and know that there's gonna be some differences. And that's where this kind of a social science idea. There's some gray areas in education where you can't say this is the one way to do it because people are just so different.
Okay. So I guess that wraps up our 30-second SLiTHER. I want to thank everybody for joining us. Justin, that was a great talk, great introduction to chemistry education research. And yeah, really, really nice to hear that. Really cut down on that, the jargon, right?
Yeah.
That's one of our fears.
A link to that book I talked about with frameworks.
Mm-hmm.
So it's hosted for free by the Chem Society in Canada. And so you can access the whole book online for free, even though Pearson wants to charge you an arm and a leg for it. So